Okay, good evening. Welcome to
MathyMath number 1.
MathyMath number 1. Why'd you pick MathyMath for this year?
There's nothing else left to pick.
Okay, good. So this is a problem we did this morning, right?
Mm-hmm.
Do you remember where it's from?
Those are the 2008 AMC 10.
Okay. Which problem?
18 or 19, I think.
Okay, I think it's 2008 AMC 10. Problem number 18, I think. And it says, you have a right triangle whose perimeter is 32 and whose area is 20. And the question is what?
What is the hypotenuse?
Find the length of the hypotenuse. Okay?
Mm-hmm.
And this morning we actually talked about two solutions to this problem. What were they?
So there's one calculating solution.
Okay, and you used algebra. And what was tricky about that solution?
Oh, there's a lot of calculating.
Yeah, there's a lot of calculating, and what made it extra hard?
Well, you had to square some square roots, and that made everything really complicated.
Yeah, so that was a tricky solution, but there was a very sneaky geometric solution, and what was it?
It would involve the in circle.
Okay.
So the in circle makes the, so this is all equal. You make a square here.
Why?
Because the tangents to the in circle, they're equal. This and this are equal.
Oh, but why does it make a square?
Because you've, this side is R, and this side is R.
Right, but why? That's what I'm asking. Why does that make a square?
Well, because it's a right triangle, the in circle, it goes off at a right angle here.
Because it's the right triangle. Makes a square. It's awesome. Okay.
So I'm gonna say this is A minus R, B minus R.
Okay, so there's one very important observation with the in circle, that the tangents that come from the vertices of the triangle are actually the same length. So that's pretty cool.
Mm-hmm.
What are some other things before this morning that you knew about the in circle?
Well, that the semi-perimeter times the radius of the in circle is the area.
Okay, what does that mean in this problem?
So that means 16 times the radius is the area.
And what's the area?
The area is 20. So then this is R is 20/16, which is 5/4.
Okay.
Is that on camera?
Just barely.
Alright, I'll get it up here.
That's fine. I can move the camera down. I just was looking at the camera. Okay, so it turns out it's really easy to find the radius of the inscribed circle in this problem. How come?
Well, because of this sneaky formula, because we knew the perimeter, so we knew the semi-perimeter,
Yeah,
and we already knew the area.
we knew the area. Yeah, so that's incredibly useful.
Mm-hmm.
So it seems like that's going to be real helpful in figuring out what's going on here. But what do we do now?
Well, there was another sneaky formula they used. I think it was semi-perimeter minus radius is hypotenuse.
Where does that formula come from, I wonder?
That's the question. So how can we prove this formula?
Yeah.
So if it would be true, that would be a great help.
Sure would. What do we know about the hypotenuse here for a right
It's
triangle?
A minus R times B minus, or A minus R plus B minus R.
Yeah, so maybe we should erase the picture now.
Alright.
Why don't we write up here that the radius is 5/4, because that's going to be useful. Okay. And we better leave the perimeter as 32, but I think we're done with the area. Okay. So what equation do we know for C right now?
So A minus R plus B minus R equals, well, this equals, we think it equals semi-perimeter. So we're trying to see if this equals semi-perimeter.
Let's not try to see. Let's just write down what we know.
Alright.
See, when you're solving the problem, you don't know there's
So
this
we know this
magic
equals
formula.
C.
You know this equals C, and that was from the picture from before.
Mm-hmm.
Okay. And we just found the radius, which was what?
Which is 5/4.
Okay. So what does that mean this equation says now?
Oh wait, a plus b minus 5 halves is c.
Okay. And what else do we know?
Well, you can do. Well, this is what we just derived from this equation.
Yep.
But we can't really say anything else about this.
No, but we do know something else.
Well, we know a plus b plus c is 32.
Aha.
So we could say a plus b minus c is, this is 5 halves.
Okay.
So then here, a plus b plus c is 32.
Okay.
So we subtract, well, we have to subtract it this way.
All right.
So we get 2c is 32 minus 5 halves, which is 29 halves. No, not 29 halves.
Definitely not 29 halves.
It's 20.
What is
Well,
it?
32 is 60. Well, it's 20. It's 29 and a half,
Okay.
not 29 halves. So then C, I think I'll just do this in halves. This is in halves. This is, so it's 58 halves. So this is in total 59 halves. So it's 59 fourths.
There you go.
All right.
Good job. Good job. So, what was important wasn't remembering whatever the magic formula was. It was just trying to say, like, what can we do here? We know one thing, a plus b minus 5 halves is c. We know that from the geometry, right?
Mm-hmm.
And they also told us the perimeter, a plus b plus c was 32. So we just rearrange those equations, subtract, and poof. Doesn't matter what the formula is. But this is how you would derive that formula anyway. So that was cool. That's a cool solution. All right. Hey, good job.